Alright, let's talk some scatter plots, huh? Alright, a scatter plot is a graph that relates two groups of data. To make a scatter plot, you plot the two groups of data as ordered pairs coordinates. Most scatter plots are in the first quadrant of the coordinate plane because the data is usually positive numbers. So, again, we'll do this in a second, but here would be like the top right section of the graph, right? It's kind of all in here because all your data values are positive. So it's going to look like a bunch of dots all over the place, and you're kind of trying to eventually look like, is there a pattern to those dots? Are they trending all up and to the right or down and to the right? Or is there no correlation? That's what we're going to talk about today. So these notes, will go over just the notes, and then we'll go over a good chunk, if not all, of the joke worksheet that goes along with it. So the table at the left shows data students collected on their test scores and the number of hours they watched TV the previous day. Make a scatter plot of the data. Ooh, fun. All right. So our first thing is the hours watched. The second thing is the test score. So usually the first thing they give you, you're going to want as your x-axis. So this would be our hours watched. And then the vertical one, the y, would be the second thing they give you, which in this case is their test score. So we just have to make sure that we scale our graph evenly. You might have different labels than your friend. We just have to make sure that we include all the values and that we kind of divide out our graph evenly. So if I look, the hours goes from 0 all the way up to 5. So we just have to make sure we include that. So we try to mark it evenly. Space them out as even as you can. So here could be 1, 2, 3, 4, 5. I did my best that I could. They're pretty even. We could even throw in little half dashes there, because I see there's like 1.5 hours, stuff like that. So try to just split the difference there. Again, not perfect, but do your best. The vertical one, I see the lowest score is, looks like 55. And the highest score, wow, nice, someone got 100. So we have to make sure that we include those values. Now, we could make this top 100 and be fine, and then kind of split it from there, make it 50 halfway. But since all our values are between 50 and 100, we could create a break in the graph. So it usually looks like a little zigzag. And that allows us to just start wherever we want. So we could start then at 50, and we could go every 10. So here could be 50, 60, 70, 80, uh-oh, I'm going to run out of room. 90, yeah, let's make 100 up here. We can throw in some little half lines there for the 5s, like 75, 85, things like that. And then we're just going to plot these points like a coordinate. So this first person watched 0 hours of TV, and they got a 92. So 0 hours, 92-ish, that's about there-ish. We're just trying our best. Maybe I'll switch up the color. I'll go with black for the dots. Probably easier to see on the video. All right, so we plotted that one. Then we have 0 hours and 100%. Ooh, well done. It's going to be this dot here. Someone got 0.5 hours, half hour, and they got an 89. So here's 0.5. 89 is pretty darn close to 90. It'll be about there. Then we have 1 hour. They got an 82. 1 hour, 82. And we just keep plotting the points like that. That one's graphed 1 hour. They got a 90. 1 hour got a 95. 1.5 hours, they got an 85. All right, it's not bad. 2 hours, they got a 70%. 270 is about there. 2 hours got an 80. It's about there. 2.5 got 65. 2.5 got a 70. 3 got a 68. It's about there. 3.5 hours was 60. 4 hours got a 65. 4.5 got a 55. And then 5 hours got a 60. We've created the scatter plot for the data. Now it doesn't ask us to analyze this, but if you kind of look, it's trending down and to the right. So that's called a negative correlation, which makes sense because you would think the more hours you're spending watching TV, that's less time you're focused on your test, right? So that's less time you could spend studying. So usually that would result in a lower score. That makes sense. So let's try another one. What else do we have here? Use the data in the table below. Make a scatter plot of newspaper circulation and the number of households with TV. All right, so the first thing they gave us was the circulation. So we're going to use that as our X, circulation. And then the TV households will be our Y, TV. All right, so the circulation I see, these are in millions. So it goes, the lowest one we have is 54 million. The highest we have is 62 million. So maybe we could create a break and go by like twos. How's that sound? So we'll create, here we'll even put millions. So we have the break, so we could start right at 52, and this could be 54, 56, 58, 60, 62. You could even split the difference there, and those could be the odd numbers in between. That'll include all of them. If we look at the TV, it goes from 4 all the way to 101. Huge spread. So we could just start this one at 0, and maybe we could make 100 up here, and then 101 would be just a little beyond that. Now, I usually like, when I'm scaling these, a lot of times I choose things that I could divide by 4, because it's pretty easy to find like a middle-ish. So if we were to find about the middle, that's about there. What's between 0 and 100? 50. And then I find the middle of those sections. Boop. Beep. That's middle-ish. Halfway between 0 and 50 is 25. So it's like we're going by 25s here. 25, 50, 75, 100. Again, my graph isn't perfect, but I did my best. So, 54 million newspapers, 4 million TVs. 54, 4. It's going to be pretty low. Then we have 59 million and 46 million TVs. 59 be here, 46, pretty close to 50, right up there. Then we have 62, 59. 62, 59, there-ish. 62, 76. 62, 76 will be a little above it. We have 62, 92. Okay, that's way up there. And then we have 55 and 101. So 55, 101 is there. Now, this is kind of all over the place. Some would say that's kind of all going up and to the right. Maybe. It's not a strong correlation. So I would say this one really has no correlation, maybe a positive correlation. So again, here kind of shows if it's trending up and right, that's going to show a positive correlation. If it's trending down and right, it shows there's a negative correlation between the two sets of data. And then if it's all over the place, that shows no correlation. Now they'll talk trend lines. We don't really need to think about trend lines very much right now. So let's look at one that's already done. The scatter plot shows the age and asking price of several used mid-sized cars. What type of relationship does the scatter plot show? If you look, they're all kind of sloping downward and to the right, which shows a negative correlation. So I would go with A on this. And that makes sense. Usually, the older car you're purchasing, it's going to get cheaper and cheaper. Obviously, we're not talking about your classic cars from 1950s, right? Those go way back up. But your used cars from the last 5-10 years, each year it gets a little less expensive in theory. All right, so we're going to do some of the joke worksheet together. Again, maybe all. I don't know. Just kind of depends on the time here. We're going to create a scatter plot for the following data sets. We have age, we have the hourly pay. Now, we're not going to use any breaks in the graph on this. We're going to go ahead and just kind of scale it as best we can. So again, I like to choose things that I can divide by 4. If you look at the ages, it goes up to 40. That's divisible by 4. So I'm going to make 40 at the absolute end there. I'm going to try to find the middle, about there. Halfway to 40 is 20, right? Woo! We'll try to split that difference. Halfway to 20 is 10, so it's like we're going by tens. 10, 20, 30, 40. We can even throw in some half marks for the 5s. The hourly pay, I see the highest one is 18. You could divide $18 by 4, but I think it's going to be easiest if we use 20. So we can just make this $20 up here. Because that's easy to split in half. Half of 20 is 10. Half of 10 is 5. So 5, 10, middle here would be 15. And then we're ready to start putting on some dots. So 17 years old, $8. 17's about here, 8's about here. We have a 20-year-old making $8.50, 20, $8.50, just a little higher. 22-year-olds making 12 bones, 22, 12-ish, there-ish. 24, 13. Again, these are just coordinates. 24, 13-ish. That should be a little further to the right. 25-year-olds making $14, 25, 14, 30, 15, 30, 15, great. 35, 16, 35, 16, and 40, 18. 40, 18, great. Now, does that show a positive correlation, no correlation, or a negative correlation? I would say that's positive. They're kind of all trending up and to the right. Now, we're not going to do all of them. Maybe we'll set up a few more scales, but then you're going to have to find the points. So if Josh Plant was doing this one, number of pets and the height. First of all, do you think there's a correlation between someone's height and the number of pets they have? Probably not. So this one would probably show no correlation. I see the height goes up to 6.5 feet. All right, so maybe we use 8 feet. Now that's going to be a bit much, but that'll be easy to divide by 4. Half of 8 is 4. Half of 4 is 2. So 2, 4, 6, 8. We could throw in some ones if we want. 1, 3, 5, 7. And then you could even make some marks for the halves if you wanted. Again, your scale might be different than your friend's, but your graphs are still going to have the same look to them. And then the number of pets went up to 6. Again, you could just go 1, 2, 3, 4, 5, 6. And you can do that. Might be getting a visitor here, and that might end this video. Let's go to the back, number 5. What type of trend does each scatter plot show? Positive, negative, or no correlation? Number 5, they're all over the place. That's no correlation. Number 6, they're all kind of sloping down and to the right. That would be a negative correlation. And then 7, they're all going up and to the right. That would be a positive correlation. Great. And then these ones. Would you expect a positive correlation? That means they both go up together. Negative correlation, that means as one goes up, the other goes down. Or no correlation, no match reel. The number of days it rains and the number of ponchos sold. If it rains more days, will we sell more ponchos? Yeah, probably. So that would be a positive correlation. A person's height and their salary. Does your height make a difference in how much you get paid? No, it shouldn't. So there should be no correlation there. No correlation. The number of times you floss your teeth and the number of cavities you get. The more I floss, the less cavities I get. So that they go in opposite directions. That would show a negative correlation. Again, I was planning on scaling some of the other ones. I just think there's someone trying to come in the class right now, so we'll end this video right there.